Today's starter is called the Crash because we're going to crash two buggy cars together. Buggy car A goes 0.5 meters per second times time plus 1 meter. And buggy car B goes 0.3 meters per second, but in a negative direction, and it starts at 10 meters. And so I want to graph A and B on the same graph, and then go from 0 to 20 seconds. And then using that graph, I want to estimate the time and the position of the crash. So I already kind of got started here. Here's my time axis. This will be my position axis. But I know I want to go from 0 to 20. But how far do I need to go from the origin up here? Well, the way you do that is you plug in your maximum value for time. And if I plug in 20 seconds right here, well, 0.5 meters per second times 20 is 10 meters, plus 1 meter is 11 meters. So I need to at least go 11. Now this starts at 10 and gets less and less. In fact, if I put 20 in here, 0.3 times 20 is -6. -6 plus 10 is 4. So I don't need to make this negative. So I just need this to go from 0 to 11. So we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 2, 4, 6, 8, 10, 12. And this is position in meters. And I don't have graph paper up here, but doing on graph paper looks a little bit better. And now I'm going to plot car A. So at t equals 0, this part goes away, and I'm left with x equals 1 meter. So that's right here. And then at 20 seconds, we already did this. At 20 seconds, 0.5 meters per second times 20 is 10, plus 1 is 11. So at 20 seconds, it's going to be at 11. Now this is just a little hand sketch, so it's not going to be perfect, but you know what? It's going to be really close. So there's car A. Any questions on that? Now where does car B start? Car B starts at 10 meters. And where will it end up? Well, 0.3 times 20 seconds is 6. If you don't believe me, just run it through a calculator. But it's negative, so it's -6. -6 plus 10 is +4. So it's going to end up at 4. So we'll just draw this across. And so car B will look like this. Now, isn't this a lot easier than plotting every point? Some people will plot every point, but you don't need to. If you know it's a straight line, you just need 2 points, and you draw a straight line. And I always pick the extremes because that makes your line a little bit more accurate. Okay, so this is car. Okay, any questions on that? Now, I want to see, when are they going to collide? Well, they're going to collide when they're trying to be at the same place at the same time, which is right here. Here they're trying to be the same place at the same time. So I'm going to go down from there. Looks like a little bit over 11. And then I'll just go horizontally like this. So just by reading off the graph, I'm going to estimate. Have you seen the little wiggly equal sign before? Right, that wiggly equal sign means approximately. And it looks like it's a little over 11 seconds on my graph. Now, I don't know if it's a little more or a little less. I'm just going to say about 11 seconds. And now I want to know what position. And I look at 11 seconds, it looks like it's about 7 meters. So I'm going to say the position of the crash will be about 7 meters on the x-axis. Okay? And those are approximations. Now, I didn't ask you to do this, but I'm going to show it to you right now. We're going to do this mathematically. We're going to figure out precisely when and where, given these mathematical models. Well, look right here. Do you see that the position of A and the position of B are the same when they are colliding? That's what a collision is, when you're trying to be at the same place at the same time. So this is the position of car A. If they are colliding, the position of car A is the same as the position of car B. Do you agree with that logic?
Yes.
Right? You're at the same place at the same time. So, well, but car A, the position of car A is equal to this expression. So we're going to substitute. So this gives me the position of car A. And in this case, at the moment it's colliding, it is at the same position as car B. So this has to be equal to this if this is true. Yes? Now all I need to do is solve for time. So what I'm going to do is I'm going to get rid of this by adding 0.3 meters per second times time. Now this is just plain old Algebra 1 or Math 1, whatever they call it now, I don't know. So this 0.5 plus 0.3 is 0.8 meters per second times time plus 1 meter is equal to 10 meters, right? Because 0.3 plus negative 0.3, this goes away. That's why we did that. Then we're going to subtract 1 meter from both sides. And if you can do these steps faster, like do 2 steps at once, that's okay. Good for you. 9 meters. And then now I can solve for time. Time is equal to 9 meters divided by 0.8 meters per second. The meters cancel. 1 over seconds is seconds. And I get up my calculator and I just say, okay, 9, oops, well, turning it on helps. 9 divided by 0.8 equals 11.25. Wow. Look at my graph. That's pretty good agreement right there. Now let's figure out the position where they should collide. So just take this time and plug it into the equation for A. So car A, 0.5 meters per second times 11.25 seconds plus 1 meter. Well, let's do the math and save the world. 0.5 times 11.25 equals 5.625, but we have to add 1 meter to it, plus 1 equals 6.625. We'll just call it 6.6 meters, a little over 6.6 meters. Hey, look, looks like it is a little under 6, or a little under 7, but now let's plug it into B and see if we get the same answer. Negative 0.3 meters per second at 11.25 seconds plus a starting position of 10 meters. Well, if we plug that in, so we have negative 0.3 times 11.25 equals negative 3.375. That's how much I reduced my position. But my starting position, I have to add it to it, plus 10 equals 6.625. Same answer. Woohoo! I did it right. At that time, at 11.25 seconds, they are at the same place. And if you use both mathematical models, both for car A and for car B, you have, and you get the same answer, you know you've done it right. But notice how close the graph was. 11, 11.25, 7, or 6.6. Pretty darn close. Really good. Graphical models and mathematical models should agree pretty well. And this was just like a goofy hand sketch. I'm sure it isn't very accurate. And yet we got really close. So this is what we're going to be doing. Any questions? Again, you did not have to do this right now. You know, all this math stuff. I just wanted you to see that we can. And that the math stuff is what we're going to be doing next. That is all.